There probably is, but I don't know it.
I wonder if he does. How many people?
You posted on YouTube? Or?
I did.
Yeah, you just look at
You know, the
videos.
truth of the matter is, it's totally up to you. If you want to blow it off, you blow it off. You know, but obviously your grade will be reflected. All right. So it's a very organized chapter. Okay. In fact, you could probably regurgitate and tell me everything that we did in the chapter, because the very first thing we did was we began solving a system of equations. Systems of equations meant they were two equations and they each had an x and a y in it. And we learned how to solve them in various ways, which we're going to get to in just a minute. But we also learned that when you have two lines that cross, there are only three possible results. Okay? The first result, that red's not very bright, is it? Is they graph parallel lines, which means it never crosses. They have absolutely nothing in common, and the answer for this is empty set. Okay, they never cross. This is called an inconsistent system of equations. Okay, you remember right at the front end of the chapter we classified these things? If they ask you to classify it, they're looking for that. Okay? The other possibility we had was when you graph them, they graph the same equation. So I put this. Yes, it was. Okay? So I graph that, and then I turn around and graph the other, and it graphs right on top of itself. Okay? This is what we call a consistent dependent system of equations. Okay? Now when we actually ask what the result was, it was infinitely many, because every ordered pair that works on one works on the other one. Okay? Then the other possibility is what we spent the majority of the chapter working on. Okay? Two lines. And they cross in one location. Okay, that is called consistent and independent. Okay? Yeah. Now, there's a way to remember. I think it's kind of easy to remember inconsistent. And remember that it probably, I don't know. Yeah, I've got it on your study guide for the most part. Okay. Dependent, if you are a dependent person, what does that mean? Like if I said you are very dependent on your parents.
Then you rely on them.
You rely on them all the time. Okay? A dependent person can be somebody, you can be so dependent on somebody that you can't be separated away from them. Okay? So this, think of those two lines, they can't be separated from each other. They're totally dependent on each other. They're stuck together like glue because they're the same line. So that's how you know this one, if it's the same line, it's dependent. Okay? Independent, they venture out. They just have one little thing that they're dependent on each other for. Okay, that one point. So it's like, oh, I'm independent of my parents for the most part, except for, I have to have a place to sleep. Okay? So this is independent, this is dependent. Now, right there at the beginning of the chapter is the only time you had to do that. The majority of the chapter was on this. How do you find that point that they have in common? If when you get down to the bottom, the variables cancel out and you might have 0 equals 5. If it's not a real statement at the end, then you know it's this. It graphs parallel lines. You also know that parallel lines have the same slope, so you could probably figure that out, okay? This one, you're gonna get, the variables are gonna cancel out, and you're gonna get a real statement at the end, like 5 equals 5. But there's no variables. So therefore you know that that's infinitely many. But the majority of everything was that one, okay? So, what's the first way that we learn to graph it, or learn to solve it? I just gave it away. Graphing. Okay. Now, when we say graphing, it's partway by hand, but it's also partway with a calculator. Okay, so that you can be for sure on it. So graphing was the very first way. So what we're going to do is we're going to take one equation, and we're going to do it every single one of these ways. Okay, the same equation, every single one. All right, so let me find an equation. Y'all with me so far? Okay. Hold on. All right, let's do this one. Here's our equation. I'm going to put it up here because we're going to do it every single way. Okay, now, if you were making a choice on us, just out of curiosity, which way would you choose? Would you do graphing? Would you do elimination? Would you use substitution, or would you use Kramer's rule? There's not a right or a wrong answer.
Probably substitution.
Substitution?
Wait, which one did you like, Colin?
That was the one that Colin
No, I
wanted,
don't
was
like
substitution.
Elimination.
I would do
Elimination,
elimination on it, and the only reason why I'm saying it is because it's set up perfect for it. Okay, my x's are over top of my x's, my y's are over top of the y's. But guess what? We don't have a choice. Okay, we're going to do it by graphing. Okay, so what is the first step that we're going to do?
Get into y equals mx.
I have to get it in y equals mx plus b form, or we cannot graph it. So that means I've got to solve for the y. So I have x plus 2y equals 6. I'm going to add a negative x to both sides. 2y is equal to negative x plus 6. Now what am I going to do?
Divide by 2.
Divide by 2. So I have negative 1/2 x plus 3. Okay, y'all with me? Alright, so that's one equation. I'm going to put that on my graph. Okay, how do I graph it?
We're gonna go up 3.
I'm going to go up 3. Put a dot. Now what?
We're gonna go down 1 and over to the right 2.
Okay, does everybody know how to do that? Okay. Ooh, and then don't
Just by a
mess.
little bit.
Alright, so that's one equation. The other equation is a little bit easier because all I have to do is subtract 2x from both sides. So I have y equals negative 2x plus 9. Do we see that? Okay. Now I can tell you right now these things are going to cross. And the reason why I know that they're going to cross is because those slopes are not the same. So they're not parallel lines. Okay, so let me put the other one on there. Okay, I'm going to go up 9 because it says the y-intercept is 9. And then I'm going to go down 2. Did it make noise? No. Okay. Down 2 and over to the right 1. I'm dependent on you, if it does, to have to tell me.
Well, I bet it makes some noise.
Okay. So it crosses. Now, my graph is definitely not accurate. So how am I going to find out where they actually cross?
You put the equations in the y equals, and then you.
Go, everybody do it. Pick up your calculator, put your equations in here. Do not call out the answer. You need a calculator.
I call it out.
No.
We don't believe in calling
I
it
did it.
down.
Show me your answer on your calculator.
I got it.
Do you have an extra calculator? I do. I have one more.
It feels like it's been so long since we've done this. I don't know why.
put them in y equals mx plus b. Then you are trying to find the point of intersection. Do you remember how to get there?
Yeah. I got it.
Yep, that's it.
Mm.
Yep.
He's like,
Hers is so much brighter than
Is
yours.
that
Did
right?
you ever replace the batteries in it to see
I
if
did
it
not.
helped?
What?
Yep.
No.
There is no point of intersection. Okay, you gotta put both of them in there.
Oh, that's wrong.
That's fine. You need two lines to be able to have a point where they intersect. Okay. Oh, I already saw yours. Remember how to get to the point of intersection? Okay.
Second, right, and then
There we go.
I'm trying to find the
Close
point of
enough.
intersection with one line.
You have to do that.
Good, good. You get it?
You know, you have
Good.
two lines to have point of intersection.
I hit the wrong button. I got both of them.
Okay.
You hit the
There it
reset
is.
button.
Okay. Okay, see where it says.
No, we can't play Pac-Man anymore.
Okay.
You hit the reset button. Now we can't play Pac-Man anymore.
Okay. Alright. Now, I'm gonna tell you something. When you go to take that test on Tuesday, don't be asking me how to find that on your calculator, because that's part of the test. Okay, so if you get there and you go, I don't remember how to find the point of intersection on my calculator, I'm gonna go, I'm sorry. Okay, yeah, that is part of the test. Okay, so I found the point of intersection by graphing. Okay, y'all with me? That that's the graphing way. And I found out that it's 4, 1. Okay? Now, the second way that we did it, well, I'm not sure which of the second ways we did it first. Okay, then we switched algebraically. Okay? And literally, algebraically has two ways. So, under algebraically, you have substitution. Did y'all just groan?
Yes.
That's really.
And then you have elimination.
Is it just gonna say solve algebraically, or is it gonna say solve by substitution?
And that's what I was about to tell you. On the test that you're going to take on Tuesday, it just says solve algebraically.
Yeah.
So you can, you can either do it by substitution or you can do it by elimination. Now, I am going to show you both right now. But because there might be somebody who likes substitution. I don't know.
Colin.
I'm
I
not
don't
gonna listen
know.
to this.
I don't
part.
know.
I did it on accident. Okay.
Okay, so we're going to do substitution first, okay, so that you can just get an idea. But on the test, it never says solve by substitution, okay? It just says solve algebraically, which would be either way. All right, oh, that's the other thing, okay? On the test on Tuesday, if you get to a section and it says solve algebraically and your mind just amazingly goes blank, okay, which happens occasionally, solve it by graphing or Kramer's rule at least get the right answer for me. Because then you'll only lose some points because you didn't do it the right way. You won't lose all the points, okay? All right, so which one of those, I don't know, let's see.
Colin.
Well, it was your way. All right, I've got to decide what I'm going to solve for. Whether I solve for the x, the 2, or the y, this x or this y. My suggestion is that you solve for either this or this, that you have an understood one in front of us. So we'll just take the top one. So x is equal to 6 minus 2y. Does everybody see how I did that? I just subtracted the 2y from both sides. Everybody with me? This becomes my key. I take this and I substitute it back in the other equation for the x. Okay, if it says x equals, then it's going to be for the x. So I have 2 times 6 minus 2y plus y equals 9. Because what it has done is it's taken away 2 variables. Now I only have one variable. I have the y. So this is going to be 12 minus 4y plus y equals 9. I have 12 minus 5y equals 9. I'm going to subtract my, something went wrong, did I? No. Yeah. Okay, hold on 1 second.
There's a 4y and then a 5y. And then like. Wait.
Hold on.
it should be
Oh,
negative
should be
3y.
right there.
See?
Okay.
Yep.
Alright, so negative 3y, and then when I subtract that, I'm gonna get a negative 3, and when I divide, I'm gonna get a positive 1. Okay? So, I know the y value. Now I plug it back in up here. Okay, back into the key. So it's gonna be 6 minus 2, which is gonna give me 4. So by substitution, amazing. I also got 4 1.
Oh.
Okay? You understand? Okay? Going back. Elimination. Okay, now, that would be the perfect one for this. Okay, so I've got it set up. This is basically what you did on that quiz, except for you did it for 3. Okay, now I need one of those coefficients to line up.
Multiply the top by -2.
Okay? Ren says multiply the top by -2. Now I don't have to do that. I could multiply the bottom with my -2 and get rid of the y. Okay, it's totally up to you whether you get rid of the x or the y. So he wants to do -2 times the top one to get rid of my x because he wants to be able to put, this has a positive 2, so he wants to figure out how to put a -2 right there in front of the x. Well, there's an understood 1 right there. -2 times 1 is going to give me the -2. Okay, so -2x plus -4y equals -12. Everybody with me? 2x plus y equals 9. Make sure you keep it nice and organized on your test so that I can see what, if I can't tell what you're doing, I'm not going to look to find partial credit if you just make a careless mistake. If you keep it organized so I can tell what you're doing, I'm going to be way more likely to spend time looking at all the details. Okay, -3y is equal to -3, so I'm going to divide by -3, and I'm going to get y is equal to 1. Then I'm going to put it back in one of those two. Okay, I can put it in here, 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 or here. It doesn't matter. Okay, so if I put it in right here, I go 2x plus 1 equals 9. I'm going to subtract. And I'm going to get an 8. And then when I divide by 2, I'm going to get a 4. Okay? 4, 1 again. Amazing. Kramer's rule. Okay? The fourth way that we did it, so everybody good so far. Okay? This is most of the way through this chapter. Okay? That's why I'm saying I don't think the chapter is quite as hard as what some of you think it is. Okay? The fourth way that we did it, I wouldn't think your favorite way, but it might have been, was Kramer's rule. That's going to be the hard way for you to remember, okay? Because that was that whole pattern thing. So let's go over that real quick. Remember that had to do with determinants, so just on a rabbit trail just for a second before we do Kramer's rule. Oh, hold on, I gotta set that again.
So do you just like make it all one video?
No,
or
I sent
do
it in
you
two.
do-
I could, I guess I could splice it together, but I don't. The difficulty is that my camera is